There's one more definition from 1.1 that we need to talk about. We say that there's an association between two variables if knowing the value of one variable helps predict the value of another. And if knowing the value of one variable does not help you predict the value of another, then there's no association between the variables. So an example would be that there's an association between the sugar count in food and the number of calories. So move on to 1.2. This is what you'll learn. I'll let you read. Please feel free to pause the video and copy down notes as we go along. I have everything filled out already, so you're not like watching me write for a long time. So just make sure that you're copying notes down, and we'll go over any questions that you have when I return. So first example is how to make a dot plot. It's pretty straightforward. I'll let you guys read this example, and essentially that this data here represents the number of goals scored by the women's soccer team 12 months in the 12 months prior to the 2012 Olympics. So to make a dot plot, the first thing we want to do is we want to draw a number line or horizontal axis. We want to label it with the variable that we're talking about. So number of goals is my label. Scale the axis. So notice that our values range from 0 to 14. So that's my smallest value is 0, largest value is 14. And then to record each data value, you just want to mark a dot above the location on the horizontal axis corresponding with each data value. Okay, so I've already done that here. And we can describe the distribution. And this is something that we're going to be practicing with a few times in your homework. So you're looking for, when you're describing the distribution, you're looking for the shape, the center, and spread, and then any potential outliers. So outliers just means, obvious departures from the pattern. So you might see right away that we have some values over here, 13 and 14, that we'll describe later as outliers. So going to the shape, and this is what you would want to, if you were asked a question about this, this is how you'd want to explain it similarly to this. So first you want to talk about the peak. So we have a peak at 4, and we have a main cluster of dots between 0 and 5. So most of our data values are on this left side of the dot plot. We have a large gap between 5 and 13, and the main cluster has a longer tail to the left of the peak than to the right. So here's our peak, and if we were to draw tails to the left and then to the right, we can see that this tail on the left is longer than the tail to the right. So the center midpoint of the 25 values that we have is the 13th value, if we count it from the end. So you might recall that that is how you find the median. So you can do it on a dot plot, just count off 13 in, and then you'll end up with the median, but they're calling it the midpoint here. We can confirm that that midpoint is 3. So if you count off, your center value would be 3. And what it tells us is that the women's soccer team scored about 3 goals during a typical game in the 2012 season. The spread, it varies from 0 to 14. And outliers are 13 and 14, and they stand out from the overall pattern. So for the next example, we're going to be, we'll actually be writing out this shape, center, and distribution. And so in this example, we are talking about the miles per gallon in a mid-size sedan, mid-size car. Here are all the values that they give us. And this is for 2012 cars. So we have a dot plot that they provided for us with all these data values. So they spaced it out by 5, they labeled it, and they have the different, notice how they're evenly spaced. That's really important with the dot plot. And so we can describe the shape, center, spread, and any outliers, similarly to what we just actually talked about. So we have the dot plot has a peak at 30 miles per gallon. So right here, the main cluster of values is from 24 to 34 miles per gallon, and there are large gaps between 18 and 23. So here's our first gap right here, and 34 through 40. And then one more gap between 40 and 48. The midpoint is at 28 miles per gallon. So a typical mid-sized 2012 car in this sample got about 28 miles per gallon on the highway. So it's really important to interpret this. It's not enough to just say the midpoint is 28. So you have to like follow up with, okay, well, what does that midpoint mean? So every sentence that I have here is significant. So make sure that you're writing down everything. The spread, the data is varying from 18 miles per gallon to 48 miles per gallon. And then the outliers, graphically, it's easy to see, and we will have a more concrete definition as to what makes it something an outlier. But we can see that these values out here are kind of by themselves. So the Hyundai Elantra and the Toyota Prius have unusually high gas mileage. So the Elantra was 40 miles per gallon, and the Toyota Prius was 48 miles per gallon. And then the Bentley had very low gas mileage. So all three cars seem like outliers. Some more definitions. If a distribution is symmetric, then it approximately looks like mirror images of each other. So I don't think any of our data values so far have been that symmetric. I guess this is roughly symmetric. Could be argued that. Probably a little, actually probably more skewed to the left. And so let's identify what that means, skewed to the left down here. It's skewed to the left if the left side of the graph is much longer than the right. And it's skewed to the right if the opposite is true. So if the right side is much longer than the left. So sometimes it can be kind of tricky to remember which one is skewed to the left and skewed to the right. So essentially, if here's a nice little graphic here. So if the tail is longer on the left, then we're skewing to the left. And you can kind of remember this if that's helpful, skew to the left. For his own safety, which way should Mr. Starnes go skewing? Last thing that we're going to talk about in this video, actually, I'm going to wait till the next video.